Hello friends. So in today's question, in a pulley system as shown in the figure, the movable pulleys A, B and C are of 1 kg each. D and E are fixed pulleys. The strings are light and inextensible. Find the acceleration of the pulleys and the tension in the string. So we have three movable pulleys A, B and C. D and E are the fixed pulleys. Okay. And we are supposed to find out the acceleration of pulleys A, B and C as well as tension in the string. So we can clearly see that entire string is, there is only one string rather we can say. It starts from point A, let us say, and goes through pulley B, then D, then pulley A, E, C and connected to finally to pulley B. So let us first of all for this C, okay, we can say there will be a mg acting in the downward direction and each is having mass 1 kg, so this is mg. Similarly for pulley C, there will be also mg downward direction and A will be also having in the downward direction as mg. Now we come with respect to tensions. Okay. So we can define that pulley C is going to have tension T in upward direction this way, and it will be in the downward direction from here. Next we come to B. B is going to have here T, and then we have here also as T, and finally we are with pulley E, which is having T in that direction. Okay, so this T will be same as E. These are basic forces which will be considered in the due course. And the important thing which we are going to consider is that the distance between the you can say centers of various pulleys. Okay, so we can say that the distance between the center of pulley E and pulley A, let us suppose it is given as YA. Okay, and distance between the center of pulley B and pulley E is suppose given as YB. Okay, so this is YB. And finally distance between the center of pulley C and pulley E is given as YC. Okay, so these are the few things which we have to consider. So we can write that a single string whose ends are tied between A and B, whose ends are tied to the center of pulleys A and B, to the center of pulleys A and B. Okay. Second, the entire string is having, or we can say the entire string is having rather same tension which is equal to T, and it is also given that weight of each pulley is 1 kg. Okay, so you can say that weight of rather mass I think 1 second. Yeah, everything is 1 kg. Okay, so we can say that, and it's also given weight of each pulley. Weight of each pulley will be equal to mg. Okay, will be equal to mg, and we considered that distance between the center of the center of, first we considered centers of pulley E and pulley A is taken as YA. Second, pulley E and pulley B is taken as YB, and finally pulley E and pulley C is taken as YC at any time t. Okay, we can say at any time t. Now you can see, if we measure the amount of string between the centers, only the centers between center of E and A, it will be equal to, and we can find out what will the what I can say, yeah, center of A and B, and similarly we find out what will be the length of the string between center of E and C, center of D and B. Okay, so we are going to use various combination to find out the distance, the amount of string between the center of various pulleys. Okay, so the amount of string, between the centers of, okay, between the centers of let us start with so first we can say we are going to have YB minus YA plus we are going to have YB, the next will be twice of YA, and plus YC, and last we are going to have YC minus YB, and this entire thing will be a constant. Okay, so first is our YB minus YA. So we can clearly see this is our YB and this is our YA. So if you minus them, we get the distance between the centers of string between A and B. Okay, so let me write it here. This is between A and B. Okay, between centers of A and B, this is YB minus YA, and next is our YB. Okay, this is between our E and B, or we can say, also we can say this as, this is between D and B. okay, because this is same. Okay, so YB, this is between D and B, string D and B. Okay, next is 2YA, sorry. Now 2YA, you can clearly see this is a combination of E and A and D and A. Okay, so this string will be YA and this is also YA. Okay, so we can say this is between E to A and D to A. Okay, so between E to A and D to A. So this E to A will be Y and D to A will be also Y, so that we are going to get 2Y. Next is our YC. So YC we can clearly see is nothing but our between E and C. Okay, so we can say this is between E to C. And last is our YC minus YB. So YC minus YB, sorry. Next is our YC minus YB. So this is our between B and C. Okay, so this string is between B and C. So entire this string will be constant at any moment of time. Okay, between A and B, even they are going to move, but since they are connected with one single string, so every length of the string between the centers will be always same. It's not going to change. So this is the important part here, and let us call this equation number 1. Okay, now double differentiating equation 1. So we can say double differentiating equation 1 double differentiating equation 1, we get or rather let us solve it here only, so it will be quite helpful. So we can say from here that this equation is equal to, this will be getting us YA plus YB and plus YB cancel out this YB and this will be twice YC, and let us call this as equation 1. Okay, so it will be much more convenient to differentiate now. So differentiating equation 1, double differentiating rather, we are going to get this as 2YA divided by dt square plus double derivative of YB divided by dt square plus twice double derivative of YC divided by t square, and this is equal to 0, and this is equal to constant. This entire thing is constant. So double differentiating is going to give us the respective accelerations. So we say that acceleration of YA is A plus YB is AB and plus twice AC is equal to 0. Okay. So we can say that acceleration of YA is equal to AA, acceleration of YB is equal to AB, and we have acceleration of YC is equal to AC. Now we are going to take the equation of motion for each pulley A, B and C. Okay, equation of motions for each pulley. So for pulley A, we are going to have, so this is pulley A, so we are going to mg in downward direction, and we also assume that acceleration is also downward. Okay, let me write it here. Acceleration of IA is AA in the downward direction, and AB is also in downward direction, and AC, let us say, is also in downward direction. Accordingly, the sign will come and we can just finally reverse in the final answer. So in case of A, we have mg in downward direction at two tensions in the upward direction. Okay, so we can draw a free body diagram for A. This is pulley A. So we have tension T, acceleration AA, and we have mg. Okay, and this is pulley A. So we can write the equation as mg and and we also have a tension T in the downward direction. So we can write mg plus T minus 2T is equal to M A A. This is capital A, sorry, AA. So from here we are going to get the equation mg minus T is equal to MAA. Okay, so let this be equation number 2. Now we can write for pulley B. Okay, we can say for pulley B, okay, if you draw the free body diagram for pulley B, so this is pulley B. In the downward direction it has two components, one is tension and another one is mg, and in upward direction it is going to have string T, and this also will be T. So the equation will be coming same. Okay, so we can write mg plus T minus 2T is equal to this is MA. I missed it. Yeah, it's okay because they are same. So this is MAB, and we can write this equation as mg minus T is equal to MAB, and let this be the equation number 3. And finally we write for pulley C, okay, and pulley C, this is pulley C, it is going to have mg downward direction, and we have tensions T in the upward direction. Okay, so, and sorry, here I missed it, acceleration is AB in the downward direction, and this is also have AC in the downward direction. So the equation will be coming as mg minus 2T is equal to MAC. Okay, and let this be equation number 4. Okay. From equation 2 and 3 we can clearly see that the acceleration will be same. Okay. So we can say from equation 2 and 3, okay, acceleration of A will be equal to acceleration of B which is equal to, as mass is 1, so we are going to, in both cases we are going to get this as okay, so we get this as both cases mg minus t. Okay, so we can put this as mg g minus t, rather it will be easy, g minus t. Okay, and AC, okay, and AC will be equal to g minus 2t. Okay, from equation 2 and 3, and this is from equation 4. Substituting value of m, we get AC is equal to g minus 2t. Next, we are going to simply solve these equations. Okay, substituting value of a, b and c in equation 1, and equation 1 was, okay, you can say using equation 1 we get, and equation 1 was acceleration of a plus acceleration of b plus twice acceleration of c is equal to 0. So we get this as g minus t plus ab is also g minus t, and this will be twice AC is given as g minus 2t. G minus 2t is equal to 0. Okay, so this comes as 4g, and this will be coming as 2t and minus 4t. 4 and 6t is equal to 0. Okay. And we already know value of, we can say this as from here 4g is equal to 6t, and t will be equal to 4g divided by 6. Okay. So taking g as 9.8, we can say tension is equal to 4 into 9.8 divided by 6, and this will be giving us tension as approximately equal to 6.5 newtons. This is the value of tension. And now we are going to find out our acceleration. Okay, so first we are going to use, you can say, both acceleration of A as well as B will be same. So we can say acceleration of A is equal to acceleration of B, which is equal to g minus t, that is 9.8 minus 6.5. So we get acceleration of A is equal to acceleration of B, and that will be coming approximately equal to, this will be 0.3 and this will be 3. Okay, so this will be 3.3 meter per second square. And last we are going to find out acceleration of C. Okay, so we can say that acceleration of C is given as g minus 2t. Okay, so g minus 2t, and we have g as 9.8 minus 2 into 6.5. So we get AC will be coming as minus of 3.3. Okay. So we can say that both acceleration of A is equal to acceleration of B, which is equal to 3.3 meter per second square in downward direction, and acceleration of C which is equal to minus 3.3, which will be meter per second square, and that will be in upward direction, okay, because of this negative sign. So we already found out tension T as well. Okay, tension T, you can write here, tension of the string is equal to T, and which is equal to 6.5 newtons. So this completes our question. Thank you.